And in our final video, we're going to talk about the smaller solid objects in our solar system that aren't quite planets. So all of these other solid materials that we find within our solar system, we're going to break it down into two groups. We're going to have dwarf planets, which are planets that are just too small for us to call real planets, like Pluto. But then we also have what are called small solar system bodies. These are just things that are smaller than dwarf planets, and they're going to include things like our comets, our meteoroids, and our asteroids. So this image is just showing us what an asteroid actually looks like. It's a small solar system body that's orbiting between Mars and Jupiter. So those asteroids are actually just leftover planetesimals. If you remember from earlier, planetesimal is those small solid objects that if they collided with other objects, they would grow in size and eventually make up our protoplanets or our early planets. But these planetesimals that were left over never really collided with anything else, so they never grew in size. So they are the remains from the early formation of our solar system 4.5 billion years ago. And most of the asteroids within our solar system are found in one area. And we call this an asteroid belt. And it's found between Mars and Jupiter, so pretty far away from the Earth. And each asteroid has its own orbit in this location, and some of them are pretty eccentric. Some are going to be nearly perfect circles, others are going to be ovals, some are going to have just really random shapes in the way that they orbit the sun. But sometimes these asteroids are capable of escaping the asteroid belt and colliding. So a lot of the time, our recent impacts that we've seen on both our moon and on Earth itself, those asteroids are coming from the asteroid belt. And if you remember the photo from our last slide, these asteroids have really irregular shapes. They're not nice round spheres like we think of our planets. Another small solar system body that we commonly hear about are called comets. And comets are basically dirty snowballs. It's just a collection of small bits of rock, dust, ice, and then frozen gases. And comets can vary a lot in size. They're going to have a very small central body and then some gases surrounding it. But in general, they're less than 10 kilometers in diameter or less than 6 miles wide. But when comets get close to the sun, the frozen gases that are a large proponent of them start to vaporize. And it's going to create two parts of our comet. We're going to be able to see a glowing head, which is called the coma. And some of them, we can actually see this long, diffuse tail that forms, like we see in this photo. And this tail will always point away from the sun. You'll be able to figure out which direction the comet is moving. And most of the comets within our solar system form in either the Kuiper belt or in the Oort cloud, very, very far out in our solar system. But we also have meteors, meteoroids, and meteorites as well. And here the main difference is where they are. If these small solar system bodies are only in our atmosphere, we call them meteors. And if we're seeing a lot of meteors falling through our atmosphere at the same time, this is called a meteor shower. And usually it's associated with a comet coming near us. So a meteor is only in Earth's atmosphere. Because we have a large atmosphere, most of these meteors burn up before they ever hit the surface. But if they do hit the surface of the Earth, we now call them meteorites. They're not only in the atmosphere, they've hit Earth's surface as well. And we're going to classify our meteorites into different types based on their chemical composition. Some of them will be full of iron. They'll be almost entirely iron, maybe with a small amount of nickel. But the other composition of these meteorites are totally different. Our second type are called stony. And these are the ones that are made out of silicates, those salty elements that might include some other minerals, but definitely not iron. And then our third type is going to be a combination between iron and stony. So our stony irons is going to be a combination of having both iron and silicate materials inside of it. When we have that meteorite hitting the surface, just like we see an impact crater on our moon and other planets, we see it here on the Earth as well. So here we're just looking at a meteor crater in Arizona where we had a large meteorite hit and deform the surface. And the last type of small solar system bodies I left for last because these are our dwarf planets. Pluto is the most famous example of our dwarf planet. Up until about 10 or 15 years ago, we considered Pluto a real planet. But we have now kind of demoted Pluto to a dwarf planet. Like the other planets, Pluto orbits the sun. It's a spherical shape like our other planets because it has its own gravity. But the big difference between a dwarf planet and a real planet is its size. With a dwarf planet, they're not quite big enough to clear any kind of debris in its orbit. With Earth, we're going to be able to move away debris as we move around the sun. But Pluto is so small that it's not capable of doing this. So unfortunately, we've demoted it to a dwarf planet. And Pluto is not the only dwarf planet within our solar system. In the last few years, we have found 3 more dwarf planets within our solar system. And there are probably even more out there that are just farther away from the sun.